Okay, let's have a look. All right, so what are we doing here? All right, so we're trying to write the transformation equation for this, right? For this situation where we want to take f of x, which is a square root of x function, and do that to it. Right, so what's that going to change? We're going to call that new function g of x, but what's that going to be? It's going to be different than just the parent function, square root of x. So this goes back to the discussion we had yesterday, that stuff, right? So we talked about what the meanings of all of the four parameters were, right? If we're taking some parent function f of x and we're going to transform that to get a new function g of x, then there's four parameters that control all the things we can do with that. We said A, which goes out in front, it controls the vertical stretch and compression, and also if you get vertical reflections, right? B, which sits on the bottom of a fraction, so the reciprocal of B goes inside the function before the x minus h, right? So that does the same stuff for the horizontally, right? So B controls horizontal stretch, compression, horizontal reflection, and then H and K just tell us how far we've translated everything horizontally and vertically. And so if we have a special point, like a vertex, that normally would be at the origin, then that's telling us where the coordinates are of that after it's been slit, right? Okay, so this is written in terms of just a generic f of x. We have a specific function this time. We've got f of x equals the square root of x. So we need to be able to write our g of x function it's somehow we're going to tweak this square root of x. We got to put a parameter in there somewhere. So what is this telling us? If we're going to horizontally stretch by a factor of 4, which parameter controls that? B does, right? And if B tells us how much the horizontal stretch is, and so what's the value of B going to be?
1 over 4.
Okay, well B is going to be 4. And so that goes in front of the x. I've got a 1 over b, which is 4. So that's my answer, right? That tells us that we took the function square root of x, and because of the location of that 4, it's on the bottom of that fraction, it tells us that we stretched it horizontally by a factor of 4. Okay? Make sense? Okay? How about the bottom one? What are we doing with this guy? So down here, same thing. We got a square root function. So g of x equals square root of x, but we maybe have to change some stuff. So what about this statement right here? If we're going to vertically stretch by a factor of 3, what's that? What's responsible for a vertical stretch? A, good. So that's telling us A equals 3. Okay, how about this? This, now if we're supposed to reflect f of x over the x-axis, so that's a horizontal axis, so what kind of a reflection would that be?
Negative.
It's going to be a vertical, right? A vertical reflection, which means A is negative, right? So that's telling us that A is actually equal to negative 3, right? And then two more things. We've got this, we're going to translate f of x 5 units to the right. Okay, which parameter controls that? H. H is a horizontal translation or slide, right? So that's telling us that H equals what? What? Now, why are you saying negative? Okay, right, because it's x minus h. But h actually has, I see what you're saying, but h actually has a value of 5. It's just that we're subtracting x, or h from x, right? So h equals 5. And everyone see what Justin's saying there? He's thinking about this. He's thinking about the fact that h is subtracted from x, right? But we're just going to subtract 5, so we get x minus 5. And then last one, 6 units down, What's that telling us?
K
Is -5, good. So where does all that stuff go? So the,
-6.
oh, -6, you're right. So the -3 goes where? Out in front. And then maybe I can move that X over a little bit. And then what about the H? So that goes X minus H, so X minus 5. And then the -6 goes out there. Right? Does that make sense? Okay, that's it. All right, so next. Okay, what about a problem like this? Yeah. Okay. Okay, so here's the goal this time. So the goal this time is to take the function that they're giving us and graph it, or select the right graph. Okay, so how would we do that? So we're given this function. Now think about the way what we're starting with, what's the parent function here? If we untweak everything, what did we begin with? A cube root of x, right? So we're starting with the cube root of x and we're doing a bunch of stuff to it to transform it, right? So first of all, we got to know, what does the parent graph look like? So what does a cube root function look like? So that's the one that's going to go up like that, like a square root, but it also goes down in that direction, right? Okay, so it's like a cubic function is the one that does this. A cube root function is the one that does that. Right? I can do that. I'm not that good at answering. Okay, so what's that? Okay, so what are looking at this function here? Tell me, what are the things that are being done? What are some values of the parameters? Because if I knew what the parameters were, I could take that parent graph and just tweak it to make the graph. Say it again.
-2 is H.
Okay, so H is -2. Everybody see that? Because we're x plus 2 is the same as x minus -2. H always has opposite the sign. This is what Justin was saying. It has opposite the sign of what shows up inside the function, right?
A is -1.
Okay, so we got a couple things. We've got H is -2. A is equal to, that's the number out front, that's -1, and what's K?
Is 5.
Okay, so if H is -2 and K is 5, that's telling us that the vertex is at the point -2, 5, right? And what does the -1 do? So now instead of going like this, what's it going to do? It's going to go like that, right? Okay, so I feel kind of dumb doing that. You get the idea. So we got to find that guy. Whoops. We gotta find that guy. So where is it? So we want to be at -2, 5. So that's not it. That's not it. That's not it. Okay, that could be it, right? So we're gonna go back 2 and up 5. That's good. And is it switched?
Yep.
It is. So it's going, right? That makes sense?
Yeah.
Okay, good. So that's it.
Wait, what do you do with the cube then? Do you have to do anything with that cube, that 3?
No, that just tells us that it's a cube root. So the parent graph is going in both directions, not just one direction like a square root.
Okay.
Right? Okay. All right. So let's try another one. Okay. All right. So what about this one? Now I want to just add one more thing to our understanding of of like the cube root functions and the square root functions. So let's look at that. Let's look at a square root first, and then we'll look at a cube root. So if this is a square root graph, let's just start with the parent function f of x equals the square root of x. Okay, so what if I put in 0 for x? I'm just going to get back the y value is just the square root of 0, which is what?
0.
0. Okay, so that gives us the point x is 0, y is 0, right? So there it is, right there. Okay, what if I put in 1? I get back the square root of 1, which is what? 1. So that tells us that it also goes through the point x equals 1, y equals 1. So if I go over 1 and up 1, there it is, right? What's another convenient one? If I put in 2, that's not a very convenient value, because if I put in an x value of 2, I've got the square root of 2, and we don't know what that is, right? Some decimal. 4 would be good. So if we put 4 in for x, we're going to get back the square root of 4, which is what?
2.
2. So that's telling us it goes through the point x equals 4, y equals 2. 1, 2, 3, 4, 1, 2. And then maybe there's one other one we could do. We could do 9, couldn't we? We could do f of 9 equals the square root of 9, which is 3. So we go over 9, so there's 5, 6, 7, 8, 9, and we go up about there, right, about 3. And so if we connect those, there's our square root graph, right? The square root graph starts at the origin, the parent graph. It doesn't go to the left, right? It only goes one direction, and it does that. Okay, so if that's f of x, what would it mean to do something? This is f of x equals the square root of x. What if I did something like this? What if I wanted to create something like g of x equals 3 times the square root of x? What does that do? Stretches it vertically, doesn't it? Okay, so that means each of the points on the graph is going to be 3 times as high as it is normally, right? So where is this point going to go? Instead of going over 1 and up 1, it's going to go over 1 and up 3, right? It's going to go up to there. And instead of going over 4 and up 2, it's going to go over 4 and up 2, 4, 6, right? See what I'm saying? So is there a phone back there? Okay. So it's going to go, if there is, put it away. So that would be 3 times the square root of x, right? What if we did also, along with that, what if we took, like, let's call it h of x equals 1/2 times the square root of x? Okay, what's that going to
It'd
do?
be lower than the first one.
Yeah, it's gonna move it down. Everything's gonna move it down by a factor of 1/2, right? It's only 1/2 as far from the graph as it was previously. Okay, so Brandon, what's that gonna do? So this point right here, instead of going over 1 and up 1, I'm gonna go over 1 and up how far? Only half as far, so I'm gonna go up 1/2. That's not super convenient though, because that's a decimal. But this would be convenient. This one normally goes up 2. So if I go over 4, how far would I go up now instead of all the way to 2?
1.5.
I'll only go 1, right? Because I'm only going half as far. Half of 2 is 1. And so that's the graph we start to draw, right? Get the idea? Okay, the same thing is true for a cube root function. We don't have to go through all this stuff over here. Let's just see what's going to happen if we tweak cube root function. So a cube root function looks very much the same. Goes through the origin. It's going to go over 1, and what's the cube root of 1? 1. So it goes over 1 and up 1. But now what's going to be the next convenient one?
4.
Not 4, because the cube root of 4 isn't very convenient. Not 9.
3.
No.
5.
So what's the first perfect cube after 1? Well, 2 cubed, what's 2 cubed? 8, right? So I could go over 8. 1, 2, 3, 4, 5, 6, 7, 8, and up 2, right? Because the cube root of 8 is 2, right? So what does a cube root look like? A cube root's going to be a little more squashed down. It's a little flatter than a square root, but it goes both ways. It's going to go in both directions, so it's just going to look like this, right? Okay, so let's tweak that. What if instead we've got, how about if we do something like f of or g of x equals 2 times the cube root of x. So where are some points that would be easy to double? Hey, would you guys just separate here. So what do we got going? Where should this point go then? Instead of going over 1 and up 1, I'm going to go over 1 and up 2. So it's going to go right there. Instead of going over 8 and up 2, I'm going to go over 8 and up 4, right? So it's going to look like that, right? Okay, what if we did h of x equals 1/2 times the cube root of x? Then instead of going over 1 and up 1, we're going over 1 and up 1/2. Instead of going over 8 and up 2, I go over 8 and up 1, right? So this one's going to look like, oops, I didn't draw that very well, but you get the idea, right? Okay, so how does that help us with this problem then? What are the values here?
A is -2.
Okay, so A is -2, H is,
1.
okay,
K is -3.
and K is -3. So that tells us our vertex is at 1, -3. And if A is -2, what's that doing?
It's reversing it.
It's reversing it and it's stretching it vertically by 2, right? So any point that would normally, where a point would normally be, it's going to get moved twice as far, right? Okay, so let's find that one. So let's see, 1, -3, that's not it. Okay, that could be it. Over 1 and down 3, there's our vertex, right? Okay, let's see if it's doing the right thing. If A is -2, then that means it should open down on the right and up on the left, which it does. This is a cube root. So let's look at a point here. So instead of going over 1 and down 1, how far should we go?
2.
2. So that's it, isn't it? Everybody see that? Right, because it should go through that point right there. A normal one would have done that. But this one's been stretched, right? Okay, last thing, then you can work. I think this is the last thing. Yeah, right here. Okay, how are we gonna do this? How are we gonna do this one?
Find A, H, and K.
Yeah, we're just gonna find A, H, and K, and there's a couple ways we could do this. Like later on in my calculus class, we would look at this and say, okay, so whatever's inside the radical, I can't put a negative number in there. So I'd have to say whatever's in there, it has to be greater than or equal to 0. And so if that would mean x plus 1 is greater than or equal to 0, and I just solve for x to get the domain. That's one way to look at it. We're not gonna do it that way for now. What makes more sense for us, where we are in the math class right now, would be to just think of this in terms of a sketch of the parent graph. So what are the values of A, H, and K here? What's A? So, okay, H is -1, good. K is, say it again? 3? Okay, so then this is a square root graph, right? So what's the parent function gonna do?
It's going to be a parabola.
So we're gonna go back 1 and up 3, right? So there's gonna be the vertex at -1, 3, and is it gonna open up or down? Up. A is positive, right? So it's gonna go over 1 and up 3, so it's gonna do that. It doesn't even really matter in this case if it's been stretched or compressed. What just matters is, does it open up or has it been reflected, right? So now from this graph, we should be able to get the domain and the range. So let's think about this in terms of x's. It's a square root graph, right? Is there a starting x value? Is there an endpoint on this graph? Well, there is, right? It starts right there. It's not defined, right? You see what I'm saying? So what is the starting x value? -1, right? So we're starting at an x value of -1, and either we're gonna go to the left or the right. Which way are we going? To the right, right? So how do we say that mathematically? We want all the x values that are what? Okay, greater than or equal to -1, exactly, because we're starting at -1 and we're moving to the right from there, right? If we move to the left, it'd be less than or equal to, right? So our domain is x is greater than or equal to -1. It wants it as an inequality, right? How about the range? Is there a starting y value? What is it? 3. So now the question is, we're starting with a y value of 3. Y is vertical, right? Are we going to go up or down from there? We're going to go up. Good. So if we're going up from there, what does that mean? Gage, what's that mean in terms of a range then? How are we going to say that? So y is what? If we're starting at 3 and going up, how do we say that? Y is what? Okay, greater than or equal to, right? Equal to because it starts at 3 and greater than because we can pick values that are bigger than 3 because it's going up. Okay, that's it, right? Make sense? So just quick sketch, go from there, right? Okay, grab a Chromebook, you can work.
No.